Hi everyone. So we are going to have to hit this pretty fast because this is a long section of notes and I really like to try to hit under 30 minutes. So 3.2, logarithmic functions and their graphs. Feel free if I'm going too fast to stop the video and pause and catch up. All right, so let's investigate 10 to the x power equals 1,000. So when I want to know what x is, I would say, well, 10 to the third power is what 1,000 looks like. Well, the exponent is actually a logarithm. So we would write log, and then we would write base 10, because this is a base of 10. And then we would put of 1,000. 1,000 is our answer. And what does a logarithm equal? It equals the exponent. Now, some of you might also remember that when you have what's called base 10, that's called a common logarithm. And another way to write a common logarithm is just to write log 1,000. If you see log 1,000, you assume that the base is 10. So what does log base 10 of 1,000 equal? 3. So 10 to what power is equal to 0.01? So that's a very small number. So we could think of this as 10 to the x, what power, is equal to 0.01 is the same thing as 1 over 100. So it's 100ths, which is the same thing as 1 over 10 squared. So if you have 10 to the x is equal to 1 over 10 squared, that's the same thing as 10 to the x is equal to 10 to the negative 2. You can bring this back up to the top. And so the exponent is a negative 2. So how do we write that as a logarithm? It would be log, the base is base 10, and the answer is 0.01. Now remember, we don't technically need the base 10, but I'll leave it there for now. What does it equal? A logarithm always equals the exponent, so negative 2. 10 to what power is equal to 100 root 10? So we're going to do a little bit of simplifying. 100 is the same thing as 10 squared, and the square root of 10 is the same thing as 10 to the 1/2 power. So remember our property of exponents, which we will use because a logarithm basically is an exponent. We would add these when multiplying. So 2.5 is going to be your power. And so 10 to the x equals 10 to the 2.5. So what does x equal? It equals 2. Ooh, I wanted a black pen instead. Let's go back to black. 2.1/2. Or you could write it as 5/2. What does that look like as a logarithm? I'll have to come down here. This would be log. The base is base 10. The answer was 100 root 10. And what's the exponent of 10? The exponent is going to be 5/2. That's a logarithm. 10 to the x equals 1 over the cubed root of 100. So we're going to rewrite this. 100 is the same thing as 10 squared. Well, let's remember this formula here. A to the m over n is the same thing as the nth root of a to the m power. So we have 10 to the 2, or we have 10 squared, and then the cubed root of it, which is this nth root of a to the m. We're going to rewrite it as a rational exponent. So that rational exponent is 10 to the 2/3 power. Remember, the 2 slides on top. The index, which is the 3, slides below. So this is 1 over 10 to the 2/3. So if we want to bring that 10 to the 2/3 up to the top, so that we have 10 to the x equals 10 to the negative 2/3, now property of exponents tells us if the bases are both 10, then x is equal to negative 2/3. So we can come here and put x is equal to negative 2/3. Let's talk about what that looks like as a logarithm. I'm sorry, I'm just kind of writing all over the place. Maybe this would have been better to write over here in your Cornell. And again, I kind of write big so you can see it. So maybe you can write a little smaller. But basically, this is log. It's base 10 again. And the answer was 1 over the cubed root of 100 before we did all this simplifying. What does that logarithm equal? It equals the exponent of negative 2/3. So the thing to know about a logarithm is an exponent. Now, this exploration is kind of fun. And when I was in high school, we used to have to look up logarithms in the back of my textbook that people with calculators were able to solve for us. So now we have logarithms on our calculator, which is amazing. But if I said, use your calculator and you're going to rewrite 1997 as a power of 10. So I'm saying 10 to what power gives me an answer of 1997. So it's a little bit tricky, but you start with 10 to the third and you realize, oh, that's too small. And then you do 10 to the fourth and you're like, ooh, that's way too big. So then you start experimenting with decimals, 10 to the 3.1, and you could do this on your calculator. And that's too small. So then you do 10 to the 3.2, and we're getting closer. And then 10 to the 3.3, and we're getting even closer at 1995. Well, so using the calculator, when you do the log of 1997, you actually get this value, which is still an approximation, but it's very close, which is 3.300378. So let me show you as far as the calculator goes. So on your calculator, the log key is to the left of 7. So if you were to look to the left of 7, you see log. So you would type in log. Now, when you use this logarithm to the left of 7, the base is base 10. And then you would type in 1997. And then the answer, oh, I didn't mean to do that 9. I meant to do a parenthesis. The answer is going to be the exponent. So you're saying 10 to what power is 1997. So when I hit enter, I get this value right here. So now you can arrow up, highlight that value, hit enter, which means you can bring that value back down. So one thing that you could try is you can take 10, you can do the raise to key, which is above the divide sign, and then you can, I believe this will work, if you arrow up, highlight that decimal, 3.300378065, it will hit enter, it'll bring it down a line, and now you can hit enter again, and you can see how close I am to 1997. So here we have y equals log base b of x is how you read it. So log base b of x equals y. If I want to take this and rewrite it as an exponential, this little dropped b is the base. The y I'm going to refer to as the exponent because a logarithm always equals the exponent, and x I will refer to as your answer. So that's how you rewrite it in exponential form. So again, this dropped is b is the base. The x, if you want to write a and w, referring to the answer, and the y is the exponent. A logarithm is always equal to an exponent. In exponential form, the b is the base, the y is the exponent, and x is equal to the answer. Now, something to note about logarithms. So logarithms, x, all right, your answer has to be greater than 0. The reason why is if you guys think about this, if you have something like 3 to what power is equal to a -9? Well, I cannot think of a number that would give me -9 in this space here, which is the logarithm, because 3 squared is equal to +9, and 3 to the -2 is equal to 1 over 3 squared, which is equal to +1/9. So it's virtually impossible for me to find a number here that's going to give me a negative answer. Because of that, x, which is this number here, has to be greater than 0. Your base also has to be greater than 0. It can't be equal to 1 if and only if x is equal to b raised to the y. So this is the exponential form of that. Note, you cannot take the log of a negative number, and that's what I showed you over here. So if I were to write the log, and this was base 3, of a negative number, my answer would be can't do it. So that question mark, there's nothing that I can find to go in it. So can't do it. You can't take the log of a negative number. Common log. Ooh, we got to move quicker. Stop repeating myself. Common log. Common log is give a positive number p, the solution to 10 raised to the x equals p. So basically, common log just means that you have a base of 10. We can, instead of having to write that 10 as the base, when we don't see a base, we assume it's base 10 when we see log. All right, natural log. Now, natural log is going to be written as y equals ln x. And a natural log has a base of that magical number, base e. So if you see ln, you know that the base is e. So here the base is e, but we don't write it. We just know that if we see an ln, it's base e. So here's the representations for that, or the notations for that. Natural log would be log base e of x, and common log would be log base 10 of x. All right, so now we're going to get right into it, rewriting each equation exponential into logarithmic. So if you look at this, let's label the parts. The base happens to be 10, and the exponent happens to be 3. And so if we come back here, log base b of x equals y. So log base b of x equals y. Therefore, b raised to the y equals an answer of x. So we're going to take the exponential and switch it to a logarithm. So we would start with log. The dropped letter is the base, and the base happens to be 10. And then the answer was 1,000. So 1,000 is your x, which equals your exponent, which is 3. Now, because this is a common log, we really don't need that 10, so I just erased it. And so you could just write it as log 1,000 equals 3. Okay, next one, 2 is the base, 4 is the exponent, and then 2 to the 4th equals 16. So it would be log, the base was 2, the answer was 16, so 16 here is your answer. And what does it equal? A logarithm always, always, always equals the exponent. So the exponent is 4. rewrite each equation logarithmic form to exponential. So here it's in logarithmic form and we're going in the other direction. So looking at this, we can see that the base is 5. The answer is 125, and the exponent, a logarithm is always equal to an exponent, is 3. So if we fill in the blanks, the base was 5, the exponent was 3, and we know 5 to the third power is 5 times 5 times 5, which equals an answer of 125. The next one, there's no base, so we know it's base 10. The exponent is what the logarithm always equals, which is 5. Therefore, in exponential form, the base is 10 raised to the 5th is equal to 100,000. Looking at example 3, we can take this logarithm and we can rewrite it into an exponential. We know that 3 would be the base. We know that 81 is the answer, and we are looking for the exponent. So how do we know what log base 3 of 81 is? We would say 3 raised to the y is equal to 81. Now, if you know that 3 to the 4th power is 81, then you could just say, all right, well, then I know that y is equal to 4, because 3 to the 4th is 81. If you weren't sure, you could take an extra step and say 3 to the y equals 81 is the same thing as 3 to the 4th. Once your bases are equal, then you can put your exponents equal to figure out that y is equal to 4. So that was your final answer, is y is 4. So let's find f of 1/16. So just another way to write it, when you see f of 1/16, that means in place of x, you're going to put in 1/16. So f of 1/16 is equal to log base 4 of 1/16. So again, how do we find the answer to that? We could take the base of 4. You could just call this y if you wanted over here. This is your output or your y. So 4 to what power gives me an answer of 1/16? Now, if you're not sure, usually, so you can see this as a fraction, which means this 4 is going to be raised to a negative number. So that's usually helpful. Otherwise, you could do 4 to the y is equal to 1/4 squared. Why did I do 4 squared? Because I'm trying to get the bases to be the same. Now, I know that I can bring this up by making the exponents negative. So 4 to the y equals 4 to the -2. Now that the bases are both 4, I can tell you that y is equal to -2, and that's going to be my solution. Y equals -2. All right, let's look at C. C is log base 5 of 1. And so 5 raised to the y is equal to the answer of 1. So again, 5 is the base. A logarithm is always equal to an exponent. And 1 is considered your answer. So 5 to the y is equal to the answer of 1. So what's y? Well, 5 to what power equals 1? We know y would equal 0 because anything to the 0 power is always equal to 1. Now, sometimes you have to use a calculator on these because we don't know f of 2.2. So if f of x equals log x, then in place of x, we're going to put in 2.2. Well, I don't know the log of 2.2. What this is asking is it's saying 10 to what power is going to give me an answer of 2.2. And I'm really not sure. So I'll come to my calculator. Let me clear it out for you guys. Clear. Okay, so we are going to do log and then put in 2.2, close the parenthesis, hit enter, and it's 0.342. We're going to round everything to 3 places in this class. So this would, what does this logarithm equal? It equals, you could put y equals, and I forgot already, 0.342. So 0.34, ooh, wait for it, wait for it, wait for it. Try again, 0.342, 0.342. Ta-da! All right, so I'll highlight that, and we're ready to go to the next example. So graphing a logarithmic function, we're going to take y equals log base 3 of x and change it to exponential form. So we know that 3 is the base. So you can see I made 3 the base. X I'm going to refer to as the answer. So equals the answer. And then y, a logarithm, is always, always, always equal to the exponent. So the exponent would be y. So 3 to the y equals x. Now this is the only graph I know of that you pick values for y, plug them in, and find x. So I just picked 0, 1, 2, -1, -2. When I plugged in 2, I got 9. When I plugged in 1, I got 3. When I plugged in 0, I got 1. 3 to the -1, when I plugged in x is or y is -1, I got 1/3 for x. And when I plug in -2 for x, no, sorry, for y, I get 1/9 for x. So then graphing these, let's fix this. All right, so graphing these, we've got 9. So you go right 9 and up 2. And then right 3 and up 1. And then 1, right 1 and up 0. Okay, so when you shift, reflect, and stretch, I always start with this point 1, 0. That's a really big point for logarithmic graphs, which is right here. And then if you go a third, you're going to go down 1. And if you go a 9th, you're going to go down 2. And so what you're going to see is you are going to see a vertical asymptote right here at x equals 0. So you're not going to cross that vertical asymptote. So this graph on your calculator is going to look like it stops, but it doesn't. It just gets really, really close to the asymptote. All right. And so there you go. That is, when you have base 3, you're going to find it's right 3 and up 1. If you have a base 5, it's right 5 up 1. When you have a base 10, it's right 10 up 1. And here's what your logarithmic graph looks like. Sort of, kind of missed that point right there. Make the point bigger and then it will go through it. All right, so domain. The domain is your left to right, and we're not going to include 0, and we're going to go out to positive infinity. The range goes from -infinity to infinity. Your intercept is your x-intercept, which is going to be 1, 0. Your asymptote is a vertical asymptote. So for vertical asymptotes, you are going to use x equals. So x equals 0. End behavior, the limit as x approaches 0. And you could put a little minus here, or no, a little plus here, meaning you're coming towards 0 from the right-hand side. F of x is going to go down to -infinity. And then the limit as x approaches infinity, which means as you go to the right, this is not approaching a horizontal asymptote. It's actually moving up forever. And so the limit would be all the way up to infinity. So you can give this transformation a try, and we will also do this transformation in class because I like doing the transformations in class. But basically, if the absolute value of a is greater than 1, a is this multiplier out front, then you're getting a vertical stretch. If it's a fraction between 0 and 1, you're getting a horizontal stretch, which is the same thing as a vertical shrink. So you could put horizontal stretch or you could write vertical shrink because those are opposites of each other. Reflection over the x-axis, you throw the negative out in front. Reflection over the y-axis, you put the negative inside with the x. H is going to shift you left or right. And H is also going to be your vertical asymptote. So let's write that down. X equals H is the vertical asymptote. And the vertical translation of up and down for the graph is going to be your plus or minus k. So you can go ahead and give this graph a try, and then we'll look at it together in class. All right, so we are almost done. We're on the last page. So let's go over some of these properties of logarithms. So the log base a of 1 is always equal to 0. So these are some of the ones that I want you to pay attention to. So it doesn't matter what a is. Log base 7 of 1, log base 10 of 1, log base 8 of 1 is equal to 0 because any number raised to the 0 power is always equal to an answer of 1. Log base a of a equals 1. So when the base and the answer are the same number, log base 12 of 12 is always going to be 1. So this is because a to the 1 is equal to itself, a. If you have log base a of a, so the base and the answer are the same thing, raised to an exponent, your answer will be the exponent. The reason why is because a logarithm is always equal to an exponent. So if you take the base of a, you raise it to the x power, then it equals a to the x power. So a to the x equals a to the x. Last property is if log base a of x equals log base a of y, then guess what? X will be equal to y. Okay, next page. All right, so last thing is just evaluating some logarithms. Evaluate log. If there's no base, we assume the base is base 10. So this is looking at the property. Notice the base and the answer are the same. And so what does log base 10 of 10 to the negative 2.5 equal? It equals negative 2.5. The reason why is if you have log base 10 of 10 to the negative 2.5 equals y, then 10 is your base raised to the y power equals 10 to the negative 2.5 power. And now because my bases are both 10, I can simply set my exponents equal, which means that y is equal to negative 2.5. However, I needed no work because I remembered that special property where the base and the answer are the same number. I get the exponent for my solution. All right. And I did this work for you here. Rewrite in exponential form is right there. Okay, so let's look at 10. So this is, you guys, 10, and then you have log, and then you have 4.1. And there's no base there. So this is base 10. And so if you think of this as equaling y, this is an exponential. And so let's change it to a logarithm. So as a logarithm, you would write log. And then do you notice this base is base 10? The answer was y. So we don't know what the answer is. Here's the y. But we do know that a logarithm always equals the exponent, which is log base 10 of 4.1. That was the exponent. Now you can see I've got that property where log base 10 of y equals log base 10 of 4.1. Therefore, I know, and here's rewriting it in logarithmic form, therefore I know that y is simply equal to 4.1. All right, solve the equation for x. We have to remember that if x is right here as an answer, the answer has to be positive. But because the answer is being squared, it doesn't matter if it's negative or positive, because once you square it, it will be positive. So log base 7 of x squared equals log base 7 of 30.